So in Python, every value has a certain data type. The variables in Python hold an object of a particular data type. Since everything is an object in Python, data types are actually classes and variables are instances of these classes. Now there are various data types in Python. First we have the numeric types, which are essentially numbers. So under numeric types we have integers, floating point numbers and complex numbers. Then we have text type data, which are in the form of strings. The third type of data that is available in Python are called as sequence types, which consists of lists, tuples and range. We have already seen about lists and tuples in our previous video. And in Python, we also have dictionary objects as mapping data types. In the previous video, you saw how to map key value pairs using dictionaries. Next, we have set data type. Now sets are unordered collection of unique items. Python also supports Boolean data types, and finally we have binary types of data, which include bytes, byte array and memory view. Now let's head over to the Jupyter notebook, where we will learn about these data types in detail. So here I am on my Jupyter notebook and I have titled my notebook as Data Types in Python. REC is for recording. So let's first start with numeric data types. I'll give a comment using a hashtag. I'll write numeric data type. Okay. Let me define a variable called num, in which I'll store a value of 7. Now let me go ahead and print the data type of my variable num. So for that I'm using my function as type. If I run this using shift plus enter, you can see here it tells me that num variable is holding a value of type integer. Now you can also use a print statement. I can write something like print num comma, I can give a message as is of type. I'll give another comma and then I'll use my function type of num. Let's see the output. You can see it here. It first gets the value that is stored in the variable num, so 7 is of type, and then it prints the class is of type class integer. Alright, I've just increased my size of the notebook. Next, let's declare the same variable num, and this time we'll store the value as, let's say, 10.8. Now you can see here there's a point, which means this is a decimal or a floating value. If you can check the type of num, it gives us num is holding a value of type float. Now let's say I'll take a negative number, let's say minus 10.8, and we'll see the type of num. Again, minus 10.8 is also of type float. Now let's say I'll declare a complex variable, let's say 8 plus 6j. Now this is a complex number, which is again of type numeric data type. If I want to check the data type of num, it gives me complex, because 8 plus 6j is of complex data type. Okay, now if you want to extract the real and the imaginary parts of a complex number, you can do it something like this. You need to pass in the variable name followed by a dot, and the attribute name is real to extract the real part of the complex number. If I run this, you can see here it has returned the real part of the complex number, which is 8. Now if you want to print the imaginary part, you can use num.imag, which is for imaginary. If I run this, there you go, it gives us the imaginary part, which is 6. Okay, now in Python you can also perform conversion of data types. So you can convert between different data types by using type conversion functions such as int, float, str, etc. So let me define a variable called num. which has a value 7.8. Now what I'm going to do is I'm going to create a variable called b, which is going to store the integer part of num, which means initially I had defined num as 7.8, which is a floating point number. I want to convert this num to integer type now, and let me go ahead and print my b, and I also print the type of num, and I'll then print the type b. Let's run this and see the result. Okay, so if you see here clearly, when I see print b, it has returned me 7, which is of type integer, so it has truncated the decimal part present in 7.8. Again, if I print type of num, so num is holding 7.8, it is of type float. After converting the float value into integer, it has given me int. Okay. Similarly, let's say we have another number minus 90.5, and if I were to check the type, I would write print type of num. Then let's convert this to integer. So I'll write print int of num. Let's see the results. Okay, so initially minus 90.5 is of type float. After we converted our num to integer, it gives us minus 90, so it has truncated the decimal point part. Alright. Now let's say I'll create another variable, let's say c equal to, let's say I'll write float of b. Now if you remember, our b holds a value of 7. If I were to convert b to float again, I can use the float type conversion function, and let's go ahead and print c. If I run this, you can see here previously b was holding an integer of 7. Now it has converted that integer into a float value, so it is 7.0 now. Okay. Now moving ahead, let's see about Boolean data types. So if I have a variable, let's say r equal to, let's say it has a value called true, which is a type of Boolean value, and let me go ahead and print the type of r. It gives me Boolean. Now let's say I'll write num greater than c. Let's go to the top. If you see here, num is holding a value of minus 90.5 and my c is holding a value of 7.0. I'm checking if num is greater than c. If I run this, it gives me false because minus 90.5 is less than 7.0 and not greater than 7.0. Suppose I create a variable Boolean or BOOL, and I'll store that value num greater than c, and let's print the type of Boolean. I'll use type of my variable, that is bool. Let's run it. You can see it here. It tells us that this particular operation is now holding a data type of Boolean. If you are getting confused, we can change the variable here. Let's say I'll write b underscore bool, and similarly I'll write here b underscore bool. Let's run it. You get the same thing. Alright, now moving ahead, let's explore how string data types work in Python. I'll give a comment as string data types. Let me scroll down. Okay, so string data types or string values in Python are passed within quotations. Suppose I have a string called str1 and it has a value, let's say Python programming, so this is a text value. I have another string, let's say str2, which has a value, let's say Simplilearn. Now let's run this. Okay, now if I were to check the type of str1, it should give me string. So str here is a string. Now you can also perform extraction operations from the string. Suppose you want to extract the value that is present in my first string, that is str1, at index number 5. Let's run it. Okay, there is some error here. Okay, so this should be str1 and not strl. Let's run it again. It returns us n. Now let's count what is present at the 5th index. So from our previous introduction to Python video, you might be aware that in Python the index number starts with 0. So if you count, p is at index 0, y is at index 1, t is at index 2, h is at index 3, o is at index 4, and then n is at index 5. So hence str1 of 5 returns n. Similarly, if you can check for other string, that is string 2, let's say I want to see the value that is present at -4. Let's run it. It gives us e. Now if you use a negative indexing operation, it will start counting from the backward position. So here n is at -1, r is at -2, then you have a at -3, and e is present at -4. So hence str2 of -4 returns e. Cool. Now you can also perform slicing operation. Suppose I write str1. I want everything that is present between the 0th index to the 5th index. I'll run it. It gives me pytho. So if you check in string 1, it will start counting from the 0th index and go up to the 4th index and exclude the 5th index. So in my string 1, if I start counting from the 0th index, so it is 0, 1, 2, 3 and 4. So it will print from P till O, and that's the result. Okay, now you can also use some inbuilt functions with string. Suppose I write str2 dot find. So I want to find the index where my m is in Simplilearn. So I'll write m within quotations and print it. It returns me 2. If you check again, so s is at 0th index, 1 is at the 1st index, and m is present at the 2nd index. Okay. Now moving ahead, let's explore a few sequence data types. So we'll start with list data type. Okay. Now first of all, let me go ahead and declare a variable called split1 equal to, and this will have some text. Let's say this is orange. Then I'm going to create another variable called L1 equal to, I'm going to split my variable or my string, that is split1, using the split function, and I'm going to split using the comma. So you can see here my string has comma I'm going to separate each of these words with a comma, and let's print L1. If I run this, you can see it here. Initially my split one was of type string, and now we have converted split one to a list. You can see this is a list and it is present inside square brackets. To verify, you can use the type function. So I'll write type of split one. It should return string. You can see it here, str. And now if I write type of L1, it gives me a list. Okay. Now let's see a few more examples. I'll create another list called list1, and let's see it has some values. The alphabet A, we have the number 1, which is in terms of string again because I have passed in quotes. Let's say I have India. Let's make it consistent with single quotations, and let me print what is inside list1. If I run it, I get my list. Now you can check the data type. If I write type of list1, it gives me, it is of type list. Now you can also perform certain operations on list. Suppose you want to add a few elements to your original list. For that, I'm going to create another variable called list2, and let's say list2 has some values, let's say b, comma 2. Now if I write list1 plus equal to list2, and let me go ahead and print list1. Let's see the result. There you go. So our initial list had 3 elements, A, 1 and India, and now we have merged or concatenated 2 more elements, B and 2, and hence this becomes our final list. Okay. Now moving ahead, let's see one more sequence data type, that is tuple or tuple. Now list and tuples we have already covered in our previous video on Introduction to Python. If you need to brush up what list and tuples are, you can check the previous video. So I'm going to create a tuple, that is tup1, and I'm going to store some values. Tuple you can create using braces. I have some value, let's say A, B, C, D, and let's say E, or let's just restrict it to D. Now you can check the type of tup1. You can see here tup1 is of type tuple. Now I'll create another tuple, let's say tup2, and it has some values, let's say E, F, and let's say G. Now if I write tup1 plus equal to tup2, and if I print my tup1, I get the result of a merged tuple which has values of both tup1 and tup2. You can see here our original tuple had A, B, C, D, and then we merged the second tuple, and it has given us E, F, G as well, and hence this becomes the final tuple. You can also perform some basic operations on tuple. Let's say I'll write tup1 multiplied by 2. You can see the result here. It has printed my original tuple twice. Okay. Now moving ahead, let's see our mapping data type, that is dictionary. Again, dictionary is also covered in our previous Introduction to Python video. You can also have a look at that video. Now the way to declare a dictionary is I'll create a variable dict1, and dictionaries are written using curly braces and have key value pairs. So I'll write my first key as 1, and let's say this dictionary is about animals, and I have, let's say, lion as my first animal in the dictionary. Then I'll create my second key. Let's say the second animal I have is tiger, and let's say my third element is a dog. Let me run it and print my dictionary. You can see this. We have the dictionary printed. Now if you want to check the type, you can write type of dict1. It returns us dict, which means dictionary. You can also print the length of dict1, and it gives us 3, which means our dictionary has 3 elements. Okay. Now moving ahead, we'll explore our set data type. Now as we understood that sets are unordered collections of values, and these values are always unique. So I'll write set1, let me give a space, equal to, again sets are written within curly braces. I'll create a set. Let's say it has some duplicate entries as well, and I'll print my set1. It returns only the unique values, so it has dropped this 5 which was duplicated. Now you can check the type of set1. It gives us it is of type, or the object is of type set. Now suppose I have another set called set2, which has values, let's say a, comma b, and let's say we have some numbers 3 and 4. I'll tell you the operation that I'm going to do. I'm actually going to do an OR operation. So I'm going to print set1 or set2. So this is an OR operator in Python. Let's print the results. You can see here it has printed all the values that are present inside set1 or set2. So in set1 we have 1, 2, 3, 4 and 5, and in set2 we have a and b. So it has dropped 3 and 4 because these are not unique, and 3 and 4 are also present in set1. Suppose I were to perform an AND operation. I'll write set1 ampersand set2. If I run this, you can see here it has only printed the unique values that are present in both set1 and set2. So 3 and 4 are the unique values, and hence it has printed 3 and 4. Let's say I'll write set1 minus set2. Let's see the results. It gives us only those values that are present in set1 and are not present in set2, which is this. Let's see the result if I write set2 minus set1. So this will return the unique values that are present in set2 and are not present in set1. So a and b are the unique values that are present in set2. Hence it has printed as a, comma b. Okay. Now another data type we had discussed was range. So range is basically a function. If I write x equal to range 4 and I'll print x, it gives us from 0 till 4, because in Python the first index starts from 0 and goes till 4. So the range is from 0 to 4. Now you can also print the type of x. It returns us a range. Now we'll see some binary data types. Binary data types are not very often used in Python, but it is better if you know. Binary data types can be written as x equal to b. Let's say I have a string. I'll write within double quotations hello world, and let me go ahead and print my variable x. You see here we have hello world, and now let's print the type of x. You see here this is a binary type which is bytes. I'll show you another operation. Let's say you want to extract a specific value from a particular index from this binary data. So again you can use the indexing operation. Suppose I write print. I want to extract the value present at the 4th index. It gives me 111. Now this is very interesting. Let's deep dive into this. Let's check what is present at the 4th index of my string. So H is present at the 0th index, E is at the 1st index, L is at the 2nd index, the second L is at the 3rd index, and we have O at the 4th index. So when we are trying to print the index position, it is actually returning us the ASCII value of small o. Now here I have a doc open which is from IBM documentation. If you see the ASCII value of small o or lowercase o, you will find that the ASCII value is 111, and hence it has returned us 111. Let's try for another index number. Let's say I want to find the value which is present at index number -2, and if I run it, it gives me 108. So -2 means it will start from the last index. So -1 is D and -2 is L. Let's see what is the ASCII value of L. If you see it here, the ASCII value of L is 108, and hence it has returned us 108. So this is how the binary data types work in Python. Now let's convert some sequence objects to other type of objects. Let's say I have a string called S which has something like Messi is from Argentina. Now you can check the type of S. Fair enough, it tells us that Messi is from Argentina is of type string. Now what I'm going to do is I'll use my list function and pass in my variable that is S, so that it converts S to a list. And let me go ahead and print my L. You can see here my string S has now been converted into a list, and this is the result. See here, these are all list elements present inside square brackets. Now if you want, you can check the type of L. It should return us list, and you can see it here. Now suppose I have another list, let's say L1, which has some numbers, let's say 1, 15, 3, 6, 0, 8, 4 and 3. Let's say we also have 1. Okay, so this is a list. You can check type of L1. Fair enough, it tells us that this is a list. Now I want to convert this list L1 to a set. Now as we know that set only contains unordered unique elements. So if I write S equal to, I'll use the set function and then I'll pass in my list variable that is L1, and let's print S. It only returns me the unique values present in the list. So it has dropped the duplicate elements such as 3 and 1. Now you can check the type of S. It gives us set. Okay, so that brings us to the end of this demo session on data types in Python. Let me go to the top and I'll brief you what we did in this demo. So first we looked at the different numeric data types. So we saw integer data type, then we saw floating data type. We also had complex data types. We saw how to extract a real part and imaginary part from a complex number. Then we used some type conversion functions to convert the numeric data types from one data type to another. So here we converted a floating type data to an integer type data. Similarly, we saw how to use Boolean data types. Then we saw about string data types. We also performed some basic operations of using indexing method to extract different values. We also saw how you can use slicing to extract a range of values from your string. We used the find function to find the index of a particular character in the string. Then we learned the important sequence data types like list. Then we had tuples. And then we learned about mapping data types such as dictionary. We also looked at set data type. Now later on we explored about range data type, and we looked at binary data types. We saw how binary data type returns ASCII value of a certain character. Finally, we converted strings to list, and then we saw how to convert list to sets.